Let's take a look at some exam questions that regard the calculation of volumes using integrals. The first one is this one. This is from June 2010, is a paper 12, component 12. And the question 2 over here, just for points. It says that the diagram shows part of the curve y equals a over x, where a is a positive constant. Given that the volume obtained when the shaded region is rotated through 360 degrees about the x-axis is 24 pi, find the value of a. Okay, so this gives a twist to the questions about the integration. You usually have to calculate the volumes. On this one, you are already given the value of the volume, and you need to find the value of the constant a. So how do you solve this? Where is it? It's over here. Well, it's the volume about the x-axis that you need to calculate. So this is pi times the integral between the limits of integration, 1 and 3, of y squared dx. What is your y? Your y is a over x. So substitute it over here, and you'll have a square x to the power minus 2, right? This equals to 24 pi. Get the primitive of that in terms of a, and here you have it. Don't forget that a is a positive constant, all right? So you'll have here now, after the substitution of x by 3 and 1, an equation in terms of a. So go ahead, you cancel the pi's, and eventually you get the two possible values of a, the positive and the negative, but it says that a is a positive constant, so you pick the positive one. All right, next one. Winter 2015, question paper 11. Question 11 as well. The diagram shows part of the curve y equals 1 plus 4x to the power of 1/2 and a point P, 6, 5 lying on a curve. The line PQ intersects the x-axis at Q, 8, 0. First, show that PQ is a normal to the curve. This first section, this first part of the question doesn't have anything to do with integrals. Is a differentiation question, so you already know that to prove that this is a normal to the curve, the gradient of this line must be times the gradient of the tangent to the curve at this point must be equal to -1. So you go to that question, and that's what you do. First, you need to get the gradient of line PQ, and this is -5/2. Then differentiate this to get the expression for all possible gradients, and then substitute x by the x-coordinate of the point where you want to calculate the gradient, that is 6, and you get the value 2/5. So this is the gradient of the tangent to the curve on point 5, 6, and this times that is -1. You have proven that they are perpendicular. Then you want the volume. Let me look at it again. You want the volume. Where am I? This is not where I am. I'm sorry. You want the volume, the exact volume of revolution obtained when the shaded region, this over here, is rotated through 360 degrees about the x-axis. Now look at this. In part 2, so in this question, you may find it useful to apply the fact that the volume V of a cone of base radius r and vertical height h is given by V equals 1/3 of pi r squared h. Now, what does this have to do with that? If you pay attention to the area that you have here, you can think of it as the combination of two sections. This one over here, let me make here a line. This over here, which you can calculate by integration, by integrating this curve about the x-axis, and this over here, which is going to, if you do that, is going to be a cone. You could indeed calculate the equation of this line and integrate it, but you might as well just use a formula. And if you use the formula, you have to imagine the cone, right? what is going to be the radius? The radius is going to be this. And how big is this blue line? Well, you have it over there. It's 5 units long. And what is the height of the cone? It is this over here. And how big is this? This is 8 minus 6. This is 2 units long. So here the h is going to be 2 and the r is going to be 5. And you have this part done. For this, just use the integral. That's what I did over here. So the volume of the shaded part is the integral from 0 to 6 of the expression of pi I squared dx, where y is the expression, okay, plus the formula here for the volume of a cone, where r equals 5 and h equals 2. Okay, so let's just do that. If you have expressions with square roots for which you have to calculate then volumes of revolution, that is the best, because if you square this, you are just canceling the power of 1/2, right? And that's what I have over here. Okay, so I just have to integrate that. The volume of the cone itself is 50/3. Then the overall result is going to be this over here. Then the last question. Wait, I just realized I said something that it wasn't entirely true a little while ago. 50/3 is not the volume of the cone. It's 50 pi over 3, okay? Now that I have this straight, we can go to the last question. This is from paper 12 from paper 11 from spring 2012. And the question is question 11. It says the diagram shows the line y equals 1 and part of the curve y equals 2 over square root of x plus 1. Show that the equation given by this expression can be written in this form. That's the first question, just 1 point. Then find the integral of this curve and hence find the area of the shaded region. And then the shaded region is rotated through 360 degrees about the y-axis. Find the exact value of the volume of revolution obtained. All right, let's take care of this first. So calculating or rewriting this expression in terms of x, just square the whole thing to get rid of the square root, then solve it for x, and basically voila, here you have it. All right, then the area of the shaded region, that's the next question, right? Okay, calculate the integral and use that to calculate the area of the shaded region. Let's calculate the integral first, okay? In this case, I decided to divide it into different integrals, and here I have the expression for it, okay? And then the area is the area between points 1 and 2, okay? And I calculated the area, yeah, between points x equals 1 and point 2, okay? So between 1 and 2 of 4 over y squared minus 1, all right? The expression that you have here. And after doing that, where am I? Here, I substituted the limits of integration, and I have 1 unit squared. Note that I could have used instead, to calculate this area, I could have used instead the calculation of the area of the curve written like this, minus the area of this rectangle over here. The result obviously should also be 1 unit squared. But if I would use this method on this question, I would have 0 marks. Why? Because the question tells me to use this to calculate the area. This is given by this hence over here, right? So you would have to calculate this in terms of y to begin with. You couldn't escape that to get this expression. And then you would have to use this one to calculate the area. All right? That's why I'm solving this integral and putting the limits of integration 1, 2 instead of 0, 3. And that's why I'm using the expression in terms of y instead of the expression in terms of x. Okay? Anyway, if I would use the integral of this minus this and between 0 and 3, this should yield also the result 1 unit squared. Okay, then it's a simple question of getting the volume of the solid that would be obtained after the rotation of the shaded region about the y-axis, okay? About the y-axis. So the limits of integration are going to be obviously 1 and 2 again, of pi x squared dy. All right, what is your x squared? Is going to be this stuff squared. All right, so if you square and you expand these brackets, you have these three terms: this square minus 2 times that plus that squared. It simplifies into this: integrate, use the limits of integration, and you will get the value 5 pi over 3.